Today we'll be looking at the composition of two functions, and our objectives will be to define what we mean by a composition, look at evaluating a composition at a numerical value, and simplifying a composition. So here's the definition of a composition: F composed with G. That's what that little circle right there means. The two functions are being composed. So the composite function F composed with G, the composition of F and G is defined by F composed with G of X is just F of G of X. So how do we interpret this expression here? So let's use some Venn diagrams here to help us. And if you look here, we input an X value and we ask ourselves, what's the first function that X gets plugged into? So the first function that X gets plugged into is G, and that produces a value for us called G of X. Then the next question is, what does G of X get plugged into? And if we look at this composition, we can see it's going to get plugged into F. So that now you apply F to G of X to produce the final outcome, F of G of X. That chain of functions, G and then F, then is what we call the composition function F composed with G. So let's look at what it's like to evaluate a composition. So suppose let f of x equal x squared minus 2 and g of x equal 5x. So let's find the value of the following two: f composed with g of 3 and g composed with f of 3. For f composed with g of 3, we just use the fact that that really means f of g of 3. Thus, we need to find what is g of 3. And if we look, g is 5 times x, so that's 5 times 3, which is 15. And we now take that value of 15 that we generated, and we plug that in to f. And f of 15 is 15 squared minus 2. That is 225 minus 2, which in the end is 223. Now, similarly, on the other side, g composed with f of 3, that is rewritten as g of f of 3. And now, instead of finding g of 3 first, we find f of 3 first. So f of 3, if we look at our definition, is just 3 squared minus 2, or 9 minus 2, or 7. And now that value of 7 that we got for f of 3, we're going to take and plug into g, and that produces 5 times 7, which we know to be 35. And so when we go to evaluate a composition, we see in both examples you evaluate the inside function first, and then the output of that function you evaluate the outside function second. So suppose you're going to have to compose f and g or g and f and find the value for several different inputs. It might be convenient for you to find an expression for f composed with g of x. So find an expression for f of g of x. And in order to do that, we just merely take f of g, and we now plug in 5x into f of x. F of x is a function that takes its input, squares it, and subtracts 2. And we ask ourselves, what is our input? Our input is g of x, which is 5x. And that ends up simplifying to the expression 25x squared minus 2. Which now, if we need to evaluate our function f of g of x at several different x values, we can just use that expression instead of using the two-part process we did in the first example. Let's do that again here with g of f of x, using the fact that g of f of x is g of f of x. So that's g of an f of x is the expression x squared minus 2. And then what does g do? G takes its input, whatever you're inputting, and it multiplies it by 5. In this case, we're inputting x squared minus 2 and 5 times the quantity x squared minus 2. You could leave it like that. We could also distribute the 5. I'd have to say both answers would probably be acceptable. And so now g composed with f of x is just the expression 5x squared minus 10. So that concludes our video about the composition of two functions, where we first looked at the definition of a composition f composed with g, we learned how to evaluate a composition, and finally we learned how to simplify a composition. So I hope you have a wonderful rest of your day.